All right, so we are going to solve the exponential and logarithmic equations. So we have these equations and we're going to solve them exactly. We're going to give the exact amount. We're not going to approximate, so we're not going to plug these into our calculator to approximate. We're going to give the exact amount. But if you want to approximate, then yeah, you can go ahead and plug this into your calculator and see an approximate for these equations, approximation. So solve the exponential and logarithmic equations. Let's start. We have 3e of x, 3e to the power of x equals 60. So how do we do this? 3 times e to the power of x equals 60. We first start off by dividing 3. That's going to give us e to the power of x equals to 20, right? So now we take the natural log of both sides like this. L of n of e of x to the power of x equals L of n 20. The natural log of 20. So we can rewrite L of n of e to the power of x as x L of n of e equals L of n 20. So the exponent, or whatever it's called, goes to the outside, just like we wrote down here. So now we got that. The natural log of e is 1. So 1 times x is obviously x, 1x. So this is x is equal to L of n of 20. That's going to be our answer. You can plug this into your calculator to get an approximation. But in this case, since we want an exact amount, this is going to be your exact amount. But let's go ahead and just plug it in just to see what we get. So L of n of 20, natural log of 20, equals, that's what it's going to equal. Just 2.995. Let's just say, no, 2.996. Let's say it's 2.996. Now let's plug it into our equation and see if it's true. 3 times, 3e, hold on a second, 3e of 2.996, I believe, was the value, roughly equals to 60. So yeah, we're pretty much good. So that was our approximation. This is our exact amount. So let's move on to the next one, number 2. E to the negative 2x power equals to 20. Again, we take the natural log of each side, so L of n of e to the negative 2x power equals L of n natural log of 20. So, same story. We move the exponent to this side, and we rewrite it as negative 2x times L of n of e equals natural log L of n of 20. Just like that. So negative 2x, blah, blah. So, again, we know that this L of n of e, the natural log of e is 1. So 1 times negative 2x is obviously negative 2x. So negative 2x equals L of n 20. And then we divide by the negative 2 because we want x by itself, negative 2. And we rewrite this whole expression as x equals negative L of n of 20 divided by 2. It's going to be your answer. Again, you can use a calculator to approximate and to plug in to check your answer. But since we want an exact amount, an exact solution, we have it right here. So the other one. Number 3. 3 to the 1 minus x power equals 4. So, yeah, since we don't have an e right here, we can go ahead and solve using logarithms, but you can solve using L of n, natural log, if you want, but for this example, we're just going to use logarithms. Take the log of each side. It's pretty much the same steps. So the log of 3 raised to the power of 1 minus x equals the log of 4. Like that. Again, we rewrite the log of 3 raised to the power of 1 minus x as the exponent on the outside. 1 minus x log of 3 equals log of 4. All right, so now we divide. We want x by itself, so we divide both sides by the log of 3. Now let's just do this. So divided by the log of 3. This obviously cancels out. Divided by the log of 3. So we're left with 1 minus x is equal to log of 4 over log of 3. Just like that. And now we obviously want to leave x by itself. We'd subtract the 1 from both sides. So this is negative x is equal to log of 4 over log of 3 minus 1. And we cannot have a negative x, we want a positive x. So we divide both sides by a negative 1 to cancel out that negative in the negative x. So this completely turns the solution as x is equal to 1. 1 divided by negative 1 is going to be, well, 1, positive 1, minus, is going to turn, since this is positive, it's going to turn into a negative. Negative log of 4 over log of 3. So that's going to be your answer. Yeah, you can go ahead and basically minus the 1 from this, but we're not going to do that now. We're just going to leave it like that. It's easier. And you can plug this into your calculator, see what you get to get your approximation to figure out if that's true. So that is your exact amount. So let's move on. Well, your exact solution. So let's move on to this one now, the last one. 30 times 10.3 to the 2a power. 2 times a power equals 100. So 30 times 10.3 raised to the 2a power equals 100. We're going to start by dividing 3 from both sides. 30, sorry about that. 30 from both sides, so it's we're left with 10.3 to a 2a power equals, this simplifies to 10 over 3. We're not going to simplify it any further than this, like using decimals, because we want it to be as exact as possible. So we're going to use the values that were given in the equation. So 10.3 to a 2a, again, we can take the natural log, or we can take the log. In this case, I'm going to go and take the log. So log of 10.3 to a 2a power equals log of 10 divided by 3. So yeah, again, move the exponent to the outside. Rewrite it by moving the exponent to the outside. 2a log times log of 10.3 equals log 10 divided by 3. Like that. So now we want to leave a by itself. We divide by 2 times the log of 10.3 to leave a by itself. This is going to cancel out except for the a. Obviously, what you do to one side, you do to the other side. So 2 times the log of 10.3. So this is going to equal to a equals log of 10 divided by 3 divided by 2 times the log of 10.3. That is going to be your exact solution. If you want, you can plug this into the calculator to get an approximation. And that is how you do these problems.